real estate is very expensive. That makes sense. However, most of the data center that we have in the United States is we have it in like in a suburban area, so the real estate is not as high. To cool that blade servers, for instance, takes about 3,000 watt per blade servers, and that is if you put about 3 or 4 of those, you can get up there 10 kW or 12, 15 kW rapidly. To cool that, and with our current infrastructure, it's almost impossible to cool that. So the next step is we're going to have to bring a chilled water system to cool that cabinet, which a lot of the vendors are starting to go to that route. So it is very difficult for us because when you start using a chilled water system in an open co-location space, and you mix up with the other co-location low density power cabinets, it's very hard to mix it up.
So are you saying actually have a chilled water plant and actually take chilled water, put it through coils in an individual cabinet, have a fan running?
That's correct. So basically it's a recycle within the cabinet. So when you have a coil, it's probably, it's going to sit in the the hot aisle, the backside of the cabinet. So all the heat will go through the coil and then recycle it back to the front side. So in order to do that, you have to have really an enclosed space. If you do that in an open space and you mix it with the other air, it's not an efficient system.
Are you guys concerned at all about having lots of water flowing around and through all of this equipment?
That's 20 years ago when I was working on a lot of the IBM facility, they used to have all this chilled water system, and nobody wanted that chilled water in their racks and cabinets. But as the technology is changing, like what you said, going to blade servers, and we can get up to 20 kW per cabinet, that's definitely an issue, and we have no way out.
Okay.
I would disagree you have no way out.
Well,
I would actually disagree that you have no way out. There are...
Sorry, can we ask you to really talk into the mic?
Okay.
People can't hear you. You really must talk
Okay.
into the mic.
Is that better?
Much better.
Okay. I would actually disagree. There are several ways of doing that, using different facilities and also sort of changing how you look at the delivery of that air. And also the question that I would ask is, how thermally efficient are those rooms in the first place?
I would love to bring you on a tour of some of our data centers, and we'll let you sweat behind some servers for a while.
Oh no, I understand that the servers are running hot. I'm not denying that. What I'm saying is that if you walk into most of the customer data centers I've been into, which is in the hundreds, most of the time they're maybe only operating at about 70% efficiency of the air that they have capacity to actually deliver. If you've got tile cutouts in the back of a server where you've got cables and that's a 4-inch by 8-inch opening, you're losing a lot of air there, as opposed to using something like closed cell foam, using something like a bristle system to don't allow that air to escape, so you're actually getting more volume at the location where you actually need to deliver that air.
All right, so I've got a 120,000 square foot floor plate, one of 5 floors, right? So, and I have to go and deliver that with disparate clients, talking 500 clients. I've got guys with, several GSRs in their space, a bunch of Junipers, tons of servers, Sunboxes, HP boxes, IBMs, E800s, Blades, every wacky thing you can imagine, and every engineering religion you can imagine. To try and engineer and do the cooling on that with all these variables, it's almost impossible. And it's a rack environment up to several thousand square feet. And some, carriers drawing average of, 40 watts a square foot. We love them, we hug them, we kiss them, they're great. And then we got these, a hosting guy comes in and they want to do 400 watts a square foot, and we blink at them and say no, and they think we're crazy. And then we have to spread them out and do all kinds of crazy stuff. It's a really difficult thing we're facing right now, and most of us are pushing it to the limits, but it's something we all have to face. I can tell you one thing, by the way, and digressing, we're back on this file. I want to say something. We'll welcome liquid cooling, glycol, dielectric spray liquid on chips, whatever it takes, because in my opinion, it's not about power. I think we can all get the power in from the utilities now. Most of us put our data centers generally in the right locations to get those, the big 13.2 feeds or whatever in from the utility. The issue is moving air or somehow getting that stuff cooled down, and either we vent it out or liquids or whatever, but that's the issue. It's really more cooling.
Oh no, cooling is definitely the biggest problem. The issue that I would raise is one of the problems is how you're thinking about the space. And that is that you're dealing with it in watts per square foot as opposed to dealing with it in the specific requirements of the rack, which is what it eventually boils down to anyway. And if you have a method of doing that, at least you have a mechanism by which you can actually charge the customer based on the amount of heat that they're generating.
I believe that what you've done is you've lowered the cost of the port to the customer, but then you've driven the cost to us as the IDC providers, where now we have to pass that cost on to customers in some form of either bigger space, charging for other services.
But if you can rationalize that to them, that's actually allowing you to make the same, if not more money, right?
Yeah, the thing is, when you have like 20 kW, 15 kW per cabinet, you try to cool that with the current infrastructure, and even if you open up that tile underneath, you can only bring so many CFM per tile, and there's no way you can cool that unless you go with the chilled water system.
What about, I actually would disagree with that. You can also do that by taking, because one of the biggest problems you have with air cooling is at some point within the height of that rack, what ends up happening is the air basically bleeds through. You're generating so much air being pulled through machines at either the bottom or the top of the rack, depending on where you're initially delivering the air, that the machines at either end of that spectrum are getting, basically, they're not getting any air. So have you actually considered using air systems that actually go from the bottom and from the top? Because now you're not necessarily, starving out for air one of those two locations, and you wouldn't necessarily have to do that with water.
Well, only thing I can tell you is you have to come out of data center and feel that we're having a hard time cooling like even 7,000 or 8,000 watts per cabinet. Those are hard to cool without a chilled water system.
Okay, because I've got one in Menlo Park, and we're doing 12, no problem, and that's only with single delivery under the floor.
Okay. So let's go to some questions from the audience. Randy?
I'm Randy Bush, IJ. I'm going to put as hot stuff in there as I can cool because I want the power. That's life. Okay, now, the problem's the cooling. Over 4,000 kW per square meter with current air cooling, you're at the limit because people walking into the pop will get blown over physically.
The wind tunnel co-location effect.
The chances of me putting water in my rack are rather small.
Actually,
we learned to take out the sprinkler systems.
right, and we have dry action sprinkler systems. How many folks here?
Well, we want tri-action cooling.
Yeah. How many folks here would be willing to have water flowing through their racks? Come on, everybody participate who would be willing to have water flowing through the racks. How many people here would say that's a deal breaker for me to have water flowing through my racks?
I think
What
the
about-
people who
what-
said yes have water on their brains.
Well, all right, what about glycol?
Look,
Everybody's scared of that. What
There's-
about dielectric liquid spraying
there's-
on your chips?
there's better ways to get airflow through the rack. Okay, you can side feed them and blow across them, etc. I'm going to sacrifice the square feet no matter what. Okay, but the fact is that most of your facilities today can't even hold 3 kW per square meter. I think any builds which aren't doing that today are unrealistic. And I would like to know which of the build providers are actually providing 3 to 4 kW per meter.
Okay.
That's 300 to 400 per square foot approximately.
I suspect the answer is none, but would anyone like to take that?
I have some cabinets at NODA, and I'll give Akamai probably the hottest customer out there. Kuju's on this, where they have one cabinet or several cabinets running about 386 watts a square foot at 75% breaker load all day long. And the reason I can cool that, they have a very big hot aisle behind them, and so they're spaced out, and they're around a lot of carriers who are running at about 40 watts a square foot, which is wonderful and great. That's the only reason we can do it. I think Patrick Gilmore told me before that we're actually their densest cabinets anywhere. at that kind of wattage per square foot load. And
Build
that's
your facility for 3K per square meter.
cool. Give me
I'm spaced out too. I'm going to have to pay for it.
give me 500 million and I'll do it.
No, your problem raising your capital is somebody putting racks in there. It's my problem to pay for the cost so you can continue to have your rice bowl filled. Okay? But the reality is that I'm going to burn as hot as I can because I want to move those stupid little electrons. Okay? And I want you to give me a facility that can take as much as you can without blowing me off my feet when I walk into it. And raise the plenum higher and start talking about, cooling's coming up, air coming up the side of the rack and crossing it.
Hello.
Currently, we are, Equinix is building like 4 kW per cabinet in the future. We're already planning on it. We're building on, going forward in 2007. It takes about close to a year and a half to
A
start.
cabinet is about a cabinet is 2 square meters essentially because you have to walk down the aisle. So that's 2 kW.
So anyways, so it's going forward, we're building that data center. And going forward, we actually are starting to separate high density users, medium density users, and low density users. So that's where we're going forward.
I think that's a wave of the future is building, high power density pods. Let's go to the back center aisle.
Hello, my name's Derek Wise from GNI. We recently went through this with our data center in San Francisco. We deployed 1,008 IBM Blade centers in a 12 cabinet environment. We're currently taking up 2,500 square feet. We have a ping pong table and I think a soda machine and some other things in the adjacent cage that we left empty. I think 200 to 300 watts per square foot is insignificant. For us, we need somewhere between 2 and 2,500 watts per square foot delivered on the floor to get the space requirements down to the actual amount. We're currently, we have the capacity to deliver.
Can you try to speak a little more to the mic?
Did you say 2,500 watts per square foot?
2,500 per square foot. If we were delivering the same cabinet space that you do, you typically deliver to about 2,000 per cabinet, 2,000 watts per cabinet, correct? And that equates to about 8 servers. We get about 84 servers right now per cabinet, so you can do the math. It's about 20,000 watts per cabinet that we're able to deliver in power, that we're able to deliver in equipment right now. That's 336 cores of processor power per cabinet that we're actually installing today.
How are you able to cool 20 kilowatts per rack?
By buying a 2,500 square foot cage and putting a cabinet there, and a cabinet there, and a cabinet there. And that's currently the solution that we have today. We don't like it. We'd like to see some kind of direct cooling environments that are available for us. I'm currently paying for it anyway. I'm paying for 100 cabinets and have 12 installed. And that's how we pay for it. So how much this cost us, we're already dealing with it today. But I'm still netting an efficiency. So I know we pick on our hardware providers pretty hard, but I want to kind of give them a little bit of kudo. I still get 3% better efficiency out of my math numbers every single month than I would if I'd put 84 1U pizza box servers in place and attempted to cool and pay for the environment that way. So there is some benefit from taking the Blade Center environments, and if our data centers can figure out a way to keep up with us, then I think we can also keep the space requirements a little smaller and maybe give ourselves another percentile or two of net gain.
A little business hat thing here, building from 100 watts a square foot is what most everybody built around 2000, 2001. And yeah, great, we're spreading it out and cannibalizing, getting to 200 watts a square foot or more is great. But when you start saying, I want to go to 200 watts a square foot baseline or 400 watts a square foot baseline, it's not a linear curve. It doesn't just, we just tack on some extra costs. It's exponential. It's obscene. I mean, there's all kinds of new technologies you have to put in place, massive generators. Oh, and by the way, it's a fun thing. Generator lead time right now for a nice 2 megawatt diesel engine, it's up to a year. Up to a year for one generator. So we can build all those raised floor or non-raised floor, do all the overhead, get it all waiting, and we sit there and twiddle our thumbs for 6 months waiting for, hopefully, our generators to get delivered. And I guarantee you all of us have, combined probably have about 40 generators on order. And then take on every enterprise, all the government, everything else. It is an exponential increase. So, where Randy says, great, pass on those costs, and I want more, more power and more cooling, just make it happen. I can't wait to see the budget trauma when we start passing on those costs, because we're going to have to. It is what it is.
The only thing that I'm proposing is let our demand generate some ingenuity. I'm not suggesting you have an answer right now that you're not deploying. I'm suggesting think about it as much as you can. We're currently paying for it. There's a better way to do it. Someone's going to figure it out in a minute. And the internet industry in general is short-sighted. We don't put enough in place to start with, or we don't really see how significant this growth can be. 22 million blade servers are going to be installed in the United States this year. And who's going to cool them? Where are they going to be located? And how are you going to handle that demand when it comes up? You're going to have mountains and mountains of empty co-location space. Anyway, so just my comment, we actually had a trial in this. We actually did the math calculations, the power sums, and did all the drawings for our environment and how we're going to have to stagger out equipment based on the facility that got us to 200 watts per square foot. And it was still a very significant burden from the amount of square footage space we had to take down to make it happen.
Okay, Bill?
There's one other dimension to this problem that I think is worth pointing out, which is when you build a brand new data center, the expected life is not just a couple of years, generally in the 10, 20, 30, 50-year type of time frame. So, I'd like to sort of shift to the other side of the table there and talk a little bit about what kind of projections those of you who manufacture this hardware see for the power consumption towards the future. Do you believe it'll continue on linearly and grow in terms of how much you need? Do you think it'll flatten out? Because those of us who are looking towards 2 to 5 years into the future have to find out some kind of measure of what we should be constructing towards. So I open that up to you guys.
So from a technology point of view, until we have the next great quantum leap, CMOS, I guess, was the last big help to us, and we don't know what that next great quantum leap is. We're going to be struggling incrementally to keep the power under control. So I see it continue to grow, and the things that can help. So the things that can help mitigate that a little bit. I think Randy mentioned a few things. We are fairly inefficient in terms of our cooling architecture, right? The amount of air that we can get through, we're forced to make bends in the air paths. And for example, on the CRS-1, where about 20% of our power goes to the fans, right? Just to power the damn fans. So that can be a mitigation. The other thing is that just spreading out the equipment, as gross as it might seem, that is a mitigation. The gentleman says he's already spacing his stuff out. Well, that's true in the router space as well as the data center space. And so, the advent of some of the vendors to do multi-chassis systems, at least for the large routers, will enable you to at least do that.
And how about Sun and Juniper? Do you guys see the power consumption continuing to grow linearly, flatten out, or?
So I believe, as my colleague pointed out, it's going to continue to grow, and it's exacerbated by the addition of features and functionalities. We continue to push wire speed performance and increase the connection density. So we go up to 40 gig connections, and that begins to take on some light in the market. All of that's going to contribute to the addition of heat within the systems. We've got more gates providing that functionality that's required, pushing it at higher speeds. And I do think we are beginning to approach the physics limits of current process technologies. So I basically concur with what you're saying there.
Cisco and Juniper agreed. Please note the date and time.
Well, it is 6606. Anyway. The other question that I would ask is, if you're talking about a 20-year sort of shelf life for your data center, if you were to go back and look at what data centers were generating from a power standpoint 20 years ago, it was actually about 5 to 10 watts a square foot. So if you look at going from 5, or let's say you go in 10 watts a square foot, even to 100 times, let's say you go to 1,000 watts a square foot, we actually have greatly increased the amount of work that can be done by well over a factor of 1,000 since then. So if you want a 20-year lifespan on your data center, I guess the one question I would ask, which is, do you expect over that 20 years for machines to be able to do the same amount of work they were doing 20 years ago, or 1,000 times? Because one of the problems we have now is, as you start to draw, when you're drawing a watt and you double that to 2 watts, it's not really a huge deal. When you're drawing, 5,000 watts, the next time you double that, that's 10,000 watts, 20,000 watts, 40,000 watts. So there's an element of geometric progression that's going on in terms of the power usage. So that's the other thing too, which is if you've got a data center you want for 20 years, how much more work do you want to be able to do within that 20-year time frame?
Just to make a statement that people can throw back in my face 10 years from now, I want to say that no one will ever need more than 20 kilowatts per rack. It's right if it was 640K, right?
Can I make a statement that he's wrong today?
So actually, I'd like to say one more thing to address your question. I'm not entirely sure that it's going to be, and history shows that yes, the progression is up and to the right as far as power is concerned. But as some of the guys have indicated, we're running into some roadblocks, and one of those things is that when you get to these 100 million gate ASICs, that you're just packing so much density and so much power into one spot, it actually becomes extremely difficult just to actually sink that power out into the system. And so with those limits, you may actually see some hiccups where it may not be linear, just because you reach a point where we'd like to add more density, but we just actually can't do it because that point source of heat is just too much. And as we've seen in like laptops on the Pentium and stuff like that, you run into just these tremendous problems of actually getting that heat from that point source out into the system.
Patrick.
Hi, Patrick from Akamai. For the colo vendors, anybody putting a colo in McMurdo base? I'm just wondering if that would be a good place.
Can you say that again? Speak up.
It was a bad joke. I asked if anybody was putting a colo in the South Pole. As a, as a brighter light, as a spot of hope, as the hottest colo in Terramark, which I will give kudos to, is the densest, best cooled colo we have on the planet, and that's saying quite a bit because we're in 2,500 locations. We are actually finding that we don't need more power. We are coming to less power. This is not true, I'm sure, for some people in the audience, but we are running into a problem where we have trouble getting enough spindles, and the processors are getting faster and dual core and drawing less power at the same time. So in the last 6 months, we have actually found that we can go from 40 amp, stay at 40 amps a rack, which is very low for us, and we couldn't even fill the rack, but that's what most colos could provide and still not have to buy empty racks so that we could cool them. And we're now able to fill them at 40 amps a rack with servers and spindles and things like that. This was not true 6 months or before. So I don't know if everyone is seeing this, but we're actually very happy that our power consumption is going down, not up. And we're getting more bits, more CPU, more everything out of the same number of amps, volts, watts. So it's not all doom and gloom. Of course, a year from now we'll need more power. But in the meantime, for the next 12 months, you guys are lucky.
I would actually like to. Briefly, the fact that gentleman's talking about CMT or, chip multiple cores on a chip, that is really a pretty big sort of leap right now that can save actually a fair amount of power. And I do work for Sun, and if you go and check out our Niagara systems, you will see that the workload that they do relative to the power they draw is actually considerably larger versus the amount of power. So whether it's us or anybody else that's doing chip multi-threading or multi-core chips, that is a way to look at to really be able to save some power, because all of the other ancillary pieces there's actually a fair amount of power there. If you really look at a machine, about only 50% of the power is actually being used by the actual processor. The other 50% is being taken up by all the other ancillary things you need to actually run the system.
RS?
Rob Seastrom. So Bill started to sort of dance around this question and kind of back into it. We've certainly seen this happen before with data centers. I remember May East Mark III with additional Liebert challengers sort of wedged in wherever they could possibly get one. The question is, if one were to build a data center to 4 kilowatts per square meter or 4,000 watts per square foot or whatever's considered the state of the art right now, how long is that premium space versus no longer state of the art, so you have to sell it at a discount? Is it even possible to do a data center with a 20-year life expectancy these days? Obviously, it's possible to sell it for some value of colo 10, 15 years from now. But the question is the run rate steep enough on the increase of power requirements that that's just a number that we're completely fooling ourselves with? And if your SEC compliance people won't let you answer that, that's fine too.
Look, this is all future thinking theory and what's going to happen from a business sense, but where all of us, we three all have internet exchanges, and we have lots of telcos and ISPs, and none of them are running at the kind of density. It's really displacement of server infrastructure that's causing the greatest heat. Or if somebody happens to have 20 GSRs in a row, that can be pretty rough too, or CRS1s or what have you, or big Junipers or whatever it is. I think what you're going to start to see is a separation of environment. The ISPs and carriers aren't going to want to build in more fiber and redeploy this infrastructure because it's a little tougher to redeploy. They're going to want to have an exchange point server ISP environment where all the carriers, voice guys, VoIP, whatever the heck it is all sitting. And you'll see a separate either modular data center in a campus environment or in a multi-story building built specifically for as a server floor. And you try and isolate that stuff. Now, as far as the future goes, 20 years from now, will it be obsolete? Maybe. Who knows? I think all of us we're all for-profit companies that we're going to, battle like crazy to keep building to satisfy our customers. And as we fill up our space, we'll find a lot next door or a lot down the road or in another city and closest to the cheapest power to acquire, which is a big thing right now too from the utilities, and build it. We're in business. So we're going to keep doing it to satisfy you guys and keep the internet working.
Joel Kraska from Viata. Question about the hardware vendors, not the server space, because processors are now becoming more efficient. What's coming in network equipment? Can you shut down part of a fabric? Can you shut down half a line card if all the ports aren't in use? Or do these things exist now, or are you thinking about them? What can you talk about?
Yeah, we certainly have. In fact, it's kind of interesting. We had a bunch of service providers come and we asked that question, and I guess the answer is if you make it automatic, so I don't have to worry about it, and nobody ever has to configure it, we'll consider it. But the response in general was pretty negative. So we have considered techniques like that. I just would remind, in terms of the bandwidth demand growth, right now it's from a router perspective anyway, and I think there's an analogy also to the CPU side. The exponential growth, technology not only is not keeping up with it, but it's plateauing. So all these various multi-threaded ideas, turning off idle portions of the logic that aren't being used. Those are all great ideas, and they're all great incremental improvements, but they're kind of like one-time things that we can try to do it in order to mitigate over the next few years. But the slope of the curve is not affected unless we either do better technology. The other thing to think about is maybe we need to just accept the fact that we need more space. There's a trade-off between space and power in terms of the density, right? Power density. So.
So today, I believe CRS1 also has high-speed, low-speed fans. So we're already doing things like high-speed, low-speed fans so that we can reduce the power required under nominal conditions and only kick up when there's thermal extremes in the environment. We're also looking at and have had similar conversations with customers with regards to acceptability of shutting down subsystems within the system. And it's typically been viewed with a little bit of a skeptical eye in terms of as long as it comes on exactly when I want it to, exactly when I need it to, but I don't want to have a protection circuit that's delayed in coming up because you're in a suppressed state, things like that. Back to also your comment with regards to having hotspots in the system. I think that's also a very valid point in terms of the density of the packages that we're putting into these systems today are pushing us in terms of being able to just design heat sinks that can sink that into the enclosure itself and get that out of a geographic hotspot within the system. We do need to look at all of the incremental changes and additions that we can, but we also have to be mindful as a vendor of the reliability requirements and the uptime requirements of our customers. So there's also been some concern expressed in terms of thermal cycling certain portions of the system and having hot and cold regions within the platform itself, and what would that do in terms of aging and long-term characterization of the equipment. So those are some of the concerns that we've heard for doing mitigation steps like what had been asked about.
Yeah, just to add one final thing on that to address your question is that we've also talked to customers about this and given suggestions as to what we could do. And one of the issues we run into is that in order to do a lot of these features where you turn down or you turn off portions of the design and then turn it back on, is that usually you have some sort of latency involved with that, where the circuit has to wake up and you have to essentially maybe buffer a packet or whatever that may be. And in a lot of cases, people are very sensitive to latency as well as to, jitter in the latency, where you may have low latency in one application and then suddenly the latency increases. That affects software, a lot of different software applications. So yes, we've had requests for that, but the pushback has been fairly large from a lot of other sources.
I think he was first.
Okay, go right ahead.
Thanks to the gentleman over there. My first question is to the co-location vendors. When will heat or BTUs be a component of the charging? And to the server vendors, when will BTUs and the heat generated from the systems be one of the elements that people make decisions upon? It sounds like
Today I said so rudely. Sorry.
It sounds like to me that there's no market for your problem. The vendors aren't able to sell on this particular issue, and I'm not charged for it.
Okay, so today, in terms of the IDCs, are you guys charging based on heat load?
No, we're not. We're charging customer capacity. We sell capacity.
Mm-hmm.
So not by the heat load.
Is that something you guys anticipate doing at some point in the future?
Power what? Power's proxy free. Yeah, I think our costs are based on delivering space and delivering power and delivering cooling. And something which you mentioned a little bit, was cooling overhead. I don't think people pay attention to that, but it's a percentage of our cost of actually delivering the space. It's wrapped into the cost that you pay us per square foot and for your power circuits. So and our costs from utilities in general have gone up in some states by 30 and 40% because of our wonderful Middle Eastern oil market. So all of that is driving other things as well, which is making it more expensive, not only our ability to build and deliver it, but all of that. Now, if any of you are happy to propose a BTU cost factor that I can charge you, I'm happy to do it. It's more money for us, right? Because we're not doing it now. So it might make it easier. I don't know.
And are you guys seeing in your RFPs now that folks are putting in, heat generation limits or requirements of any kind? Is this something you guys are starting to see?
Absolutely, yeah. And, I mean, a lot of our customers have kind of hard limits due to legacy buildings, right? So and the way we've kind of approached it is kind of may seem silly, but building smaller systems with less slots is one way to approach it.
This is true.
The other,
So not directly the dimensions you're asking about, but we have had people inquire about power efficiency for the routers in terms of gigabits per kilowatt, for example, as a way of measuring system capacity for comparison's sake.
Okay.
The other thing also is a lot of education. When you look at total cost of ownership for any device, whether it's a switch, a server, what have you, that total cost is dependent not only on the hardware, software, support cost, but also the power cost. And you're getting devices now, you can go and buy a server for $700, and at 8 cents a kilowatt hour, which is sort of pretty close to what we pay in this area, for example, it's actually going to cost you more over the course of a year to power and cool that box than it will be for the cost of the box.
That's extremely interesting.
Lane Patterson, Equinix. Quick question to the vendors. I think an interesting point might be to A T640, if you were to redesign that today, what fraction of the power budget would it require compared to the existing model? And if you project that ahead to the next generation of stuff that you build, what I hear is people saying, hey, I can do 4x the density and speed and throughput with only 30-40% more power. How much of that decision making goes into your next generation of, hey, I have to come up with something that I can fit in the same power footprint as my last gen?
So, in terms of developing product requirements to meet those kinds of requests, we are seeing definitely requests for holding the line on power density, but we're also seeing requests for increases in throughput and capacity. So I don't think it's practical for me to be able to go forward to my customers and promise a doubling of capacity and holding power consumption flat, but we're definitely working towards trying to reduce overall system capacity through whatever mitigation steps we can take in the course of the design. So I guess what I want to leave you with is it is not an afterthought. It is being factored into requirements and being synthesized into the engineering process from the ground up as we're going forward.
I guess I would just reiterate that we're at a point now going forward in the future where we have to, there's probably a set of tricks in our bags that we haven't used yet. So we can probably hold, we can hold the line somewhat over maybe a generation or two, and that's what we'll do. And going forward beyond that, I think we have to maybe think about alternative architectures for POPs.
Immerse the racks in liquid nitrogen. You guys get that stuff ready, and we'll lower it in the tanks and put out the maintenance.
I'll throw out one question that I have kind of to the audience is that in terms of there is somewhat there is a space versus cooling efficiency trade-off that we can make to some degree. So would it why don't we build POPs that are in cheaper locations and backhaul more stuff?
Yeah.
That's why you backhaul it.
You backhaul the traffic.
Hi, Jared Mach, NTT America. If I have to backhaul more stuff, I have the challenge of right now I'm seeing individual customer growth that is rather huge. The numbers as far as customer growth that I've heard earlier today seem about right for traffic. And right now, no vendors are providing interfaces greater than 40 gig right now. And not in the foreseeable future, certainly not in at least the next 2 years, am I going to be able to do anything faster than that, based on rough estimates and timelines that I've heard. And so backhauling stuff means that you're aggregating more stuff in a single location, and you need faster link speeds in those locations as a result of that to be able to deal with that. So that's not really an option. In fact, it's really more of a trying to fix. Well, I'm sorry.
Wavelengths?
There's significant problems, as you may know, with any sort of hashing algorithms to balance stuff across multiple wavelengths. So if I have individual customers coming to me and delivering 10 gigs of traffic to me in a location, and they're going to be doubling that every year for the next several years, how am I going to be handling that over long distances, local distances, and such if the fastest interface speed I can get is 4x that internally? And this is a significant engineering challenge that I think we're all really facing. And as the media companies continue to do what they've been doing recently, which is saying, hey, we can make money selling TV shows on the internet in the past 6 months and stuff like that, and sell movies and whatnot, I think it's really going to be a significant thing, and we may see past the 2x growth for a little while as people start to get the faster FiOS services into their home and everything else. And it's without any sort of faster capacity out of the vendors for the individual link speeds. This is a huge challenge, and this really has me personally actually somewhat scared about what we're going to be doing about this to solve it in long term.
Okay, we'll just be taking questions from the people who are standing up right now, actually, since we're almost out of time. Over here.
Avi Friedman. I talk to a lot of people who are looking to do storage, video streaming, Usenet news, things that are very, very disk intensive. I'm interested that Rackable, I don't know whether Rackable Systems was invited, but I see them a lot for people who are looking for very dense disk solutions. And I also have a question for Sun regarding the coming Thumper product. 48 disks for you, you know, sort of no matter how many processors you have in it, looks like it starts to generate a lot of heat. So first question is, what is the heat profile of a rack full of those? Second question is there any work to do something like a 4U 196 laptop disk box? Does heat really come into it for people who are basically saying, I need IOPS, or, you know, I just need so many terabytes of storage per rack unit?
I can't give you a specific answer on that because those products, well, they showed up in Jonathan's blog. They haven't actually shipped yet. I can tell you that that area is being looked into. I think the other thing that we're looking at, whether it's from, you know, a blade box full of disks or a blade box full of processors, there are going to be certain limitations that we're going to tell people. And it's going to pretty much be, if you want to put this in, you've got to sort of show us that you have the capacity in the location you're going to put it in to cool it. Or, thank you, Yan-Yon, good night. That's one of the other things that, you know, there's a responsibility that we have to make sure that we can give you accurate power information on, you know, that type of work. The other responsibility is also to the people who are installing it to make sure that they're installing in a location where it can meet the requirements of the box that it has. And I think that's one of the areas where historically a lot of vendors, including Sun, have really sort of dropped the ball, which is letting people go and install stuff in areas where they couldn't realistically support it, particularly from a thermal standpoint. And that does cause failures. We know that if you're running stuff very, very hot, it will decrease the mean time between failure. So I think that's one of the other things that we're working on now, and I know some of the other vendors are as well.
Okay. Randy. Oh. Okay, off to the right.
Yeah, I'd like to just suggest that, this is Phil from IS Prime, Phil Rosenthal. The worst offenders in terms of hardware really are not the people that are on the panel. In fact, they're pretty good, all things considered.
That's why they showed up.
Exactly. And I'd like to point out to the audience that they really should be putting pressure on the vendors that are producing these one-use servers that, if you look at the profile of where the power is going, greater than 50% of the power is going towards the processors. And I don't know about everyone else's, but for us, if you look at a server, say for example, a Dell 1650 from 5 years ago versus a Dell 1850 today, they're doing similar bandwidth because the customers have similar needs. We have more of them. And the processor time, they're sitting at 90% idle on both of them. So do we really need these bigger, faster, more power-hungry processors in greater density for our bottom-of-the-line servers that you can buy today? I really think that that's not the case, and vendors really need to start offering more power efficient, you know, using laptop processors instead of Xeons. And also, I'd like to point out what Patrick said, that they're reaching a plateau in terms of disk density. I know for a fact that a lot of the vendors we're buying from are going to start distributing servers using smaller, miniaturized, basically laptop drives, but with higher performance spindles. So you're going to see greater density for that coming very soon. And there wasn't really a question. I just wanted to make a statement.
Excellent comment.
There is one area, and this is true for, you know, basically all the vendors that are working on it, which is the area of virtualization. And that, you know, the biggest issue there particularly from a power and cooling standpoint, which is the point that the gentleman made, which is most of those machines are only doing they're not idle 90% of the time. So I guess one of the other questions is if you could actually get your machines to actually be in use 80% of the time in that workload that they're doing, would you need nearly as many of them sucking nearly as much power and generating nearly as much heat? Show of hands, anybody?
I think one thing we see in the market now, particularly in the hosting market, is that there's really a widespread adoption of virtualization. I think a lot of the dedicated hosting market in particular is, except for the higher end managed hosting, the I'm going to rent a Dell box market is starting to rapidly go by the wayside in favor of virtualized private servers. I mean, so that's definitely being seen in the marketplace.
Yeah, I'd like to make another comment on that. Vendors, what we have seen, I think what I kind of like what they did is that we have seen our neutral current is dropped quite a bit because of a lot of the servers now these days, they require 208 volt instead of 120 volt. That eliminates the neutral phase that generates less heat to the data center as well. So that's something that you guys did really well.
Woohoo! Randy.
On my left, I've got a large crew singing, "I want my P2P." Yeah, I'll virtualize. Yeah, I'm squeezing it down. But I got more of them. So I'm still going to have max heat in the rack. I'm talking intimately with the router vendors and some of the server vendors. They're working real hard to do what they can. But when I go to the colo vendors, in 2000, went to the newest facility in the Redlands, this is technology that's now 6 years old. We weren't even using the latest stuff we were trying to install then. We had to leave 1/3 of the facility empty. We were going to open a bistro in it. Bill, you tell me you're designing for 50 years. You're not designing for today. I'm trying to tell you I need 3 to 4K per square meter today. And other people who are trying to stick blade servers in are twice that. And that's not tomorrow, that's today.
Okay. One last comment or question.
Tim Alicio with New Mantra. To what extent, and I'd like to hear this from both sides, opinions on both sides, to what extent do you think standardization of things like, let's say, using larger, more efficient power supplies, or standardizing cabinets so you get a better airflow, or you can reduce having to have internal cooling fans, which also are going to suck power. To what extent do you think that can help mitigate this problem, and are there any efforts in that area going on right now?
Okay. Let's start with the hardware guys.
So I think that actually could be very helpful. I know that there are some efforts on if you go into like the IEEE meetings, there's some efforts on the physical layer side to look into power reduction. But whenever you standardize something, generally you get the economies of scale, you get the more research and development investment. And we've seen that if we look at our products, and I look at the standardized products that go into our design versus the non-standardized products, in general, just the economies of scale and the amount of investment that goes into it, you get a much more efficient product.
I think that one thing that might help would be, I think we're working towards, at least in the kind of the telecom router area, we're working to kind of old standards. So I think a new standard that redefines what a rack really means, maybe something that looks at what airflow architectures really mean. I think that would be a big help. The other stuff, yeah, we can get the more dollars we get into a particular area, we can do a better job of optimizing. But I think we're kind of hamstrung again by technology. I keep harping on that subject.
So standardization along the lines of things that you're talking about, mechanicals, airflow systems, things like that would go a great deal towards helping the situation within the context of a system in and of itself. I think we're always going to see optimized designs for specific products internal to the system, but the enclosures, the physicals, and the outside plant, from the router's perspective, it would help a good deal if there was something that resembled design guidelines or a target to shoot towards. And there again, you'd be working on top of economies of scale that colleagues have spoke to.
There is a lot of standardization that's going on, from everybody's trying to use, multi-speed fans and use them when you need them and stuff like that. The biggest change I think you're going to see is that now there are sort of three organizations right now: SPEC, which is actually working on a power benchmark; the Echo Forum, which is being driven by the EPA. They're actually looking at trying to actually create an Energy Star metric for servers.
Energy Star blade servers.
Yes.
Yikes.
At some point, I mean, this is one of the things that we're working on right now, and then also what's called the green grid. And so what you're going to start to see as these benchmarks start to come out and customers really start to ask for it, which is all the vendors, whether it's the server vendors, the storage vendors, the network vendors, one of the things that they're going to be able to compete on is how much work are you doing given how much power are you sucking and how much heat are you generating. And that's actually probably the single biggest thing that the users, our end user customers, and all the people who buy this in the industry can actually do, which is make us compete on how efficiently we use power and generate heat, because then you're going to decide with your dollars who's going to win. And when it comes down to who's going to make money doing this, and if I can create a more efficient power utilization server at a given load than my competitor, and you're actually going to buy it, that motivates me to find other reasons to do it. But to say, I'm not, you could save all the power you want, but I'm still not going to buy your product, well, that sort of tells us, guess what? You're not willing to pay for power efficiency. So part of it is you have to tell us, and you also have to vote with your dollars, as it were.
It's nice to have metrics that you can measure to help compete, but I'm thinking specifically, are the vendors talking to each other about ways that they can do things in common ways so that they can be more efficient if they're working together at a data center, if they're adjacent to each other at a data center, let's say, or they want to interact with what the carriers, what the facilities might have built.
The one thing that has happened, which is ASHRAE, the American Association of Heating Refrigeration Engineering, has come out with a spec that sort of says, okay, machines need to be cooled front to back, and fans need to be variable speed and stuff like that. And so at least that is one small area that you have a lot of vendors now that are trying to build machines that at least meet those specs. I don't think personally, and this is just my own personal opinion, you're going to actually see vendors wanting to work together. I mean, I certainly don't want to tell, HP how to build cooler machines that draw less power, because that's a competitive advantage for me. There are going to be some standards, but in terms of things that we really think are a leap forward, say some stuff that we did with chip multi-threading, we don't want to make that publicly available and give it to my competitor, because that's the way I can make money. I can differentiate myself in the market.
Okay. Very briefly, just to wind things up, this has been an excellent panel. I'd like each of the folks on the panel on both sides, in 30 seconds or less, to give one thing that they would like to see the folks at the other table do to help the situation, just to sort of wind things up. So let's start at the end.
Well, I think basically from the data center side, we would request for vendors to, as they say, design more efficient power supplies, more efficient equipment, because at the end of the day, we have to figure out a way of how to dissipate that heat out of the data center, and that's our biggest challenge.
Okay.
Well, we've been, with Equinix, we've been challenged by the power density, and customers a lot of times they do not understand the statement of like spreading out the load. They like to put everything in a condensed mode or compact, smallest cage as possible. We want them to understand the heat load and able to dissipate the heat. You need to understand we need to distribute these cabinets, spread them out, so that we can cool you guys properly.
We're all building really hot, well-powered big data centers now. I think I'd like to see all the vendors come into our IDCs, not enterprise data centers, but IDCs, which are a combination of enterprises and ISPs and hosters and everything, and start testing their hardware in a real-world environment. Let's work on thermodynamics and fluid dynamic issues and bring it into our data centers. We all have labs. We'll put it in the middle of the floor and see if it melts something or doesn't. and we'll put some glycol taps in it, we'll put some liquid stuff, see what happens, and we're happy to do it because it benefits us and our customers later on. Building a data center is a slow-moving iceberg. Building a server might be a lot faster. It takes a long time to build a data center, so let's work together on that.
I do have one more thing here. When you guys are not using the rack, if you're not using a certain the space, use a blanket, the blanket, so you can isolate the cold aisle to the hot aisle. So it'll help the airflow much better.
That's interesting. How much do you think that in an average facility, would putting a blank up, how much do you think that would help?
Oh, it'll help a lot.
Really?
It'll really help a lot. Right now, you got a lot of leakage going from cold aisle to the hot aisle. So if you cover that up, you're going to have a lot better, it's efficient, very efficient system.
That's actually the fluid dynamic comment I was talking about. I think that's what got him inspired. That you have a 7-foot 42U cabinet, and the middle of it is totally empty. The air, and you're in a raised floor environment. The air is going to flow up through that hole and shoot back, and the top servers are going to run it in 99 degrees. The ones below there are going to run at 72 degrees, and then everything's going wrong, and you're complaining to the vendor, and it causes all kinds of operational and flow control issues for us. You put blanks in, holy cow, it all works, and it's much more efficient, and there's less cannibalization of space going on.
Okay, hardware guys.
First answer that I can tell you on all of our stuff, we actually supply those now. And if you actually go to PG&E's website, we actually did some work with them recently to actually try to measure what the increased efficiency is if you have those blanks, and it was fairly sizable. The biggest thing I would ask is, one is education, not just amongst yourselves, but also to your customers, and to please stop using watts per square foot to define your data center. It is a fundamentally flawed view of the world because it's making the assumption that the heat load is even, and across a data center it never is. If you really start dealing with it in terms of a per rack basis, that makes it a lot easier to understand and justify the requirements that you have. So that would be the one thing that I would ask.
So for me, what I'd like to actually see, and this goes back to one of the questions out there, is that if all the IDC groups got together, and if there was some sort of forum or group that could actually work with us, we'd be very happy to do that. One of the issues that we run into in a lot of our customers is everybody has different requirements, and we try to fit all these requirements into our design, and it turns out that then we're sort of basically doing trade-offs for all these requirements, and we can't optimize for any one application. But if we had a sort of a general consensus across the board, we could probably do it much more effectively.
I guess for me would be, again, to get together, I think that the last question had a good suggestion in terms of standardization, or get a group of the IDC people. We need to get some service providers that do their own facilities, and vendors such as Force 10 and Juniper and Cisco, and try to strategize on what a facility architecture should look like for the next generation. I think we've been dealing with legacy architectures for too long. So I'd hope we'd come up with an architecture that would make cooling easier, make the airflow easier. That would go a big ways to helping us reduce the amount of power that we consume just in fans, for example. So.
Today as a vendor, when we see RFPs from our customers, they're all over the place with regards to what the requirements for the environmentals look like. Maybe that's a little bit of hyperbole, but they are quite diverse in the needs that we see. So it would help a lot to have some common standards that people are shooting towards in terms of data center designs. Also, to update some of the nomenclature would help a great deal, as you were describing, with regards to taking a look at the amount of power for the amount of work required. From the router perspective, we look at things in terms of gigabits per kilowatt consumed, or the reciprocal of that, kilowatts per gig that's necessary. So some common language like that, I believe, would help us a lot as well.
Thanks. I'd like to thank the panel for the great work. I'd like to thank Michael, David, Brad, Rob, Josh, Jay, and Brian. Outstanding job. Thank you.